Hello everyone, welcome back to our channel. This week we are going to be looking at a request for a statistics question, specifically from the May-June 2024 Paper 2 exam. So we are going to be looking at number 5 of this paper. Without further ado, let's get into it. Okay, so for the first part of this question, part A, we are given a table here which represents the results of a spelling test. So in the spelling test, each student was given 10 words, and the number of words they spelled correctly is represented on the top row, and the frequency, or how many times this result was obtained, is represented on the bottom row. So usually with these questions you get a count of something. In this case, the frequency is the count and the something is the number of words. So for example, if it's 5 out of the students who got this exam, 8 of the students got 5 words correct, and then you have 4 students who got 6 words correct. So the frequency represents the number of times that you got these results in the top row. Okay, the number of times that it occurred. So the first part of this question is asking us for the mode. What is the mode? The mode is simply the most frequent observations. Okay, so the most frequent observation will be the number of words that corresponds to the highest frequency. So if you look at the frequency row, the highest frequency is clearly 8. So the mode will be the number of words associated with that, which is 5, because 8 students, which is the highest frequency in this table, received 5 words correct as their result. Okay, so the next part of this question is asking us for the median. So what is the median? Well, simply put, the median is the number in the middle. So what does that mean? If I were to go up to this table here, remember that frequency represents counts of students who received this result in their spelling test, whether it's 5 words correct or 6 words correct. Okay, so if you were to line up all of these numbers and represent these numbers in this data in a different way, what would that look like? All you need to do is find the one in the middle. So you could keep going right down the line, right? Write 7 2 times, etc. And we need to find a number in the middle. So first things first, what is the number in the middle? So if you know that these numbers here represent the counts of the students, then the total number of students would be the sum of this. So if you were to add up everything, it would give you 23 students in total. So what's the number in the middle there? So if you notice, this is an odd number. So if we just divide 23 by 2, you get 11.5, and then you round it to the nearest unit, you would get 12. So the number in the middle is equal to 12. So we just simply have to go to figure out which one is 12. So let's see. 8 students got 5 words correct. Okay, that's 8 down. And then the next number is 4. 8 plus 4 is 12. So up to this point, we are at 12 students. So therefore, 12 students, when you get to 12 students, the number of words we are talking about is actually 6. So therefore, the median in this case is equal to 6. Okay, so the next part of this question requires us to find the mean number of words spelled correctly. So I'm just going to scroll back up to calculate this so we can be closer to the table. Okay, so how do we calculate the mean number of words? So I'm just going to work on the top left corner here, where the mean is equal to the sum of fx over the sum of f. What does that mean? So in this case, x here would be the number of words, and the frequency is f. Okay, so the sum of fx. So first we need to calculate fx. Okay, so that's simply multiplying 8 by 5, which would give me 40, 6 by 4, 7 by 2, 8 by 2, 9 by 3, and 10 by 4. So to go back to this equation on the left hand side here, the sum of fx would be the sum of each of these numbers that we just wrote on the right hand side here. 40 plus 24 plus 14 plus 16 plus 27 plus 40. So that would actually sum to 161. And the sum of f, if you recall, we already calculated as on the right hand side here, where there are 23 students. Okay, so the sum of f, we already know, is equal to 23. So I'm just going to write that in. So when you work this out, you're going to get 7 students. And that's the answer for part 2 of this question. Okay, so for part B of this question, we have a different set of data. In this case, we have the times recorded in minutes by each student by an attendance officer who is recording the time taken by each student to travel to school. So on the x-axis here, we have time in minutes, and on the y-axis, we have cumulative frequency. And this is just the same data represented here, where your frequency, cumulative frequency, is just representing the counts, right? So for us, at any particular time here, let's say 10 minutes, if you were to go up from 10 minutes and go across the y-axis, this will represent the students who arrived in 10 minutes or less, right? So all the students who arrived before or equal to 10 minutes would be this part of the curve here. And similarly, if you were to look at 20 minutes, if you wanted to know how many students arrived in 20 minutes or less, you would go up to the curve from 20 on the x-axis, and then you go across to figure out what the frequency is. And the value here would be the total number of students, because remember, frequency in this case is also students, just a different set of data. It's going to represent how many students arrived in 20 minutes or less. So let's look at the first question here, the first part of this question. The number of students who took at most 32 minutes to travel to school. So this is just like what we've just been talking about. We're talking about 32 minutes. So first we need to locate 32 minutes on the x-axis. So I've already gone ahead and drawn the line. 32 minutes in this case is represented by the blue line. Okay, because every one of these small blocks on the x-axis represents 2 minutes. So if you go up to the curve and then across to the y-axis to get a cumulative frequency, that actually corresponds to, so I'm going to write it here, 52, sorry, 52 students. Because if you look at where this line is, in the middle here would be 50, and each half a block corresponds to 2 students in this case. So therefore, this blue line is at 52 students. So that's your answer for part 1. So the next part of this question is asking us for the interquartile range. So I'm going to go back to the next page so we can answer this question where we're close to the curve. Okay, so I went ahead and defined the interquartile range on the top right here. And that is the range between the 75% mark and the 25% mark. Or another way to look at it is just the 3/4 mark or the 1/4 mark. And what do I mean by that? So if you remember when we were looking at the median, and we had 5 occurring 8 times, and then we just line up all the numbers like that, and I mentioned we could just line them up like soldiers and find the number in the middle. It's exactly the same thing, except here it's easier to do it. We can just do it directly from the graph using the cumulative frequency on the y-axis. So in this case, the amount of students that we have is 220 students. We already know the total amount of students, so it comes like the y-axis is the students lined up. as we just talked about. So we need to find, just like the median would be in the middle, we need to find, so the median will be somewhere around here, whatever the half of here is, which should be like between 110 and 111, but we'll get into that shortly. So it'll be somewhere around here for the median. We are focusing on the 75% or 3/4 mark or the 25% mark, because we need to find the difference between those in order to get the interquartile range. So let's first start with the 75% mark. So we need to find 75% of 220. Now in this case, 220 is not an odd number, it's an even number. And what that means, let's look at a simple example right in the middle here. So like if I were to have like, let's just say 4 numbers, and I need to find the number in the middle. What's the number in the middle here? You don't actually know. So a good way to think about this is it's simply the number in the middle will actually fall in the middle of these two. So I'd have to say 2 plus 3 over 2 and find the average. And the average there works out to be 2.5. Okay, and as you can see, 2.5 is exactly in the middle of 2 and 3. So when you have an even number, as we do in this case with 220, we actually need to find the average of the two middle numbers to get the number that's in the middle of whatever range we're talking about. So the same thing applies when we're trying to find 75% of 220. So when you work this out, you would get 55, right? So the number we're actually talking about would be 55 plus the next number, 56 over 2, which is just 55.5. Okay, so this is the 75th number. Actually, this would be the 25th number that I'm working out here. Sorry, is equal to 55.5. This, and now we have to look at the 75th percentile, which is 75 over 100 multiplied by 220. And this gives me 165. And again, we need to find the middle number. So we'll be looking at 165 plus 166 and finding the average of those, which is 165.5. So for the 25th percentile, we need to find the time that corresponds to 55.5. And for the 75th percentile, we need to find time that corresponds to 165.5. So I've actually already gone ahead and drawn these lines. This is what you see in red, the red lines on this graph. So let's look at the 25th percentile, as this is the one that we looked at first, and that corresponds to 55.5. So when I went onto the y-axis, I found 55.5, because that's the point that I need. I went across to the curve, and then I looked for the corresponding time at that time. So in this case here, I'm just going to also write this in so you guys can follow. This is the 25th percentile mark. And this one on top of here is the 75th percentile. Right? And then, of course, the numbers, the time it corresponds to on the x-axis is what we're trying to find. So if you follow this, the 25th percentile corresponds to the number 33 at the bottom. And this one, if we follow it all the way across and down, this actually corresponds to the number 54. So I'm going to go back to the right hand side here where we have our definition of the interquartile range. So we know it's going to be the difference between the 75th percentile value, which in this case is 54, and the 25th percentile value, which in this case is 33. So the interquartile range would be 54 minus 33, and that is going to give me 21 minutes, because this is our time in minutes. And that brings us to the end of this question. Okay, so for the final part of this question, part C, we are given letters written on separate cards and placed in a bag. And Dacia is picking 2 of these cards at random with replacements, and we need to calculate a probability. We need to find the probability that she picks the letter I, then the letter V. So how do we do that? Well, let's start with the first thing. Let's first figure out what is the probability that she picks the letter I. So how we would write that is the probability that she'll pick an I. How we find that is we first need to figure out how many I's there are, and you put that number over the total number of letters that there are. So how many letters do we have? If you check these, you would find that we have 10 letters. Okay, so out of 10 letters, how many of them are I's? We have 1, 2, 3 I's. So that gives me 3 over 10. Let's then find the probability of picking a V, because that's the next letter she's going to be picking, right? So what's the probability of that? Okay, again, it's the same 10 letters, because what they said here that the letters were picked with replacement. So after they pick the I, the first letter, they put it back. So the amount in the bag remains at 10. So how many V's do we have in this bag? So we only have one V here. So therefore, the probability of picking a V would be equal to 1 over 10. So, but it didn't ask us for these two probabilities separately. They asked us for the probability that she picks an I, and then the probability that she picks a V. Now in this case, these two events are completely independent, because the probability of picking a V does not at all depend on the probability of picking an I. She picked an I, you put back the letter, and then she picked another letter. So because these two events are independent, and you're trying to find the probability of one and the probability of two, what you'd have to do is multiply the probabilities of the two independent events. So let's just look at this. So this one again is 3 over 10, and the probability of picking a V is 1 over 10. So because of the and these two events being independent, we can multiply the probabilities. So that's what we're going to do here. And when you multiply that, you get 3 over 100. So the probability is 3 over 100. And that brings us to the end of this question 5 of this past paper. Thank you for watching, and we will see you back here, hopefully, for the next episode.